Hi guys, so we are all live now. Can you hear me?
Hi guys, so
Okay, great. Cool. We had an interesting question today. Uh, I mean, it's interesting, but it's not, I would say, it's not a hard one. Of course, it's not a hard one, it's tagged as medium. In medium, also, it's at a slightly lower level, I would say. Okay. So, yeah, I'm interested to know that how many of you could code it on your own. You can just say yes if you were able to read, understand, and code the question all on your own. It's a long story that the question has. So I think we need to read it and clearly understand the problem statement. So as you can see, it says you are playing a video game where you are defending your city from a group of n monsters. So you can imagine there are going to be n different values which will be supplied to me. So we are given as, now here it comes. So you are given a zero indexed integer array distance of size n, where dist of I initial is the initial distance in kilometers of ith monster from the city. Okay, so let's understand it in this manner. This is your city, let's say New Delhi, and then there are different monsters who are standing away from your city at different distances. Okay, so let's say the first monster is standing at a distance of 1 kilometer, the second monster is standing at a distance of 3 kilometer, and the last monster is standing at a distance of 4 kilometer. So these are the distances of the monsters, and these monsters are actually approaching towards your city. Okay, cool. Now there is one more array. It says that the monsters walk towards the city at a constant speed. The speed of each monster is given to you in an integer array speed of size n, where speed I is the speed of ith monster in kilometers per minute. Okay, so all these three monsters are initially at this much distance, and they are also moving with some speed. So let's say their speeds for now are equal to this. uh, Understand it that the speeds could be different also. Here coincidentally it is the same, but it can be possible that the speed of third monster is maybe 2 units per time, right, per minute or whatever. Now the question says that we have a weapon. Once fully charged, it can eliminate a single monster. So let's say we have a weapon, and if initially the weapon is fully charged, it says it here, and it also says that if it is fully charged, it can kill a monster instantly. Instantly it can kill a monster. Now it says the weapon takes 1 minute to charge. So if let's say you have used the weapon to kill first monster, whoever you want to kill, then you have to wait for 1 minute. You have to wait for 1 minute for the weapon to be charged again, so that you can use it to attack. Okay, now you lose when any monster reaches your city. So it's obvious, I mean, there are n monsters approaching your city and you are killing them with your weapon, and if at any instant any monster touches your city, that means you're gone, that means you lose the game. Now it says if a monster reaches the city at the exact moment when the weapon is fully charged, it counts as a loss. So this is just an edge case scenario, but it's important to understand it. So let's say if at any instant of time the monster has actually arrived at the city, has touched the city, and during that time your weapon has completed its charging, then it will be considered that you have lost. Okay, cool. And the game ends before you can use the weapon. Yeah, so that's what it says. Now what you have to do is you have to return the maximum number of monsters that you can eliminate before you lose. Okay, or n if you can eliminate all the monsters. So well and good, if you can kill everyone before anyone touches your city, then the answer will obviously be n. Otherwise you just say how many monsters you can kill. There is a very simple example to it. Like when I take this particular example itself, what will I say? I will say that, hey, I have been given these two arrays, and we all know that we have a weapon with us. The weapon is initially charged. Okay, because it is initially charged, so it is initially ready for use. Because it is ready for use, so you can use it and you can kill whichever monster you want to kill. Now one more thing, if you look at the constraints, it says that distance of I is always greater than equal to 1. So guys, it is never so going to happen that at the beginning itself there is a monster who is touching your city. It will never ever happen. All the monsters are going to be separated by some distance, and that distance will be at least 1. Now given the fact that our weapon is initially charged, can I say we can definitely kill at least one monster? Can I say that? Of course, because the moment the game starts, the weapon is charged and the weapon kills the monsters instantly. So it is guaranteed that I can randomly pick a monster and kill that monster, right? Now there are a few common sense based questions that I would want to ask you. So which monster would you want to kill first? If at all you have to, let's say you are in middle of a game, you are standing with a gun and there are different monsters who are approaching towards you, then which monster would you want to kill first? So Rachit says the monster who can reach first. Okay, others? The nearest one, okay? Somebody says nearest one. Okay, for that, let's take a slightly different example and understand that. Let's say the distances given to you are 6 and then 10, 15, and the speeds given to you are 2, 5 and 3. Now answer me one thing, which monster is nearest to you? It is the first monster who is nearest to you, right? Now would you want to kill this monster? The answer is no. You would not want to kill this monster. Rather, you would want to kill this monster. Why? Because although this monster is farther than the other, but because its speed is higher than that, so it will end up reaching you earlier. So if I just try to figure out the time taken by them to reach your city, how much is that going to be? 6 divided by 2, which is 3, 10 divided by 5, which is 2, and 15 divided by 3, which is 5, right? So this guy, this monster is going to reach your city fastest, and because he or she is going to reach your city fastest, so it makes much more sense to kill this monster, right? See, in the other case, let's say the speed of this guy was even higher. Let's say the speed was 10 units. If the speed was 10 units, this monster would have reached you after 1 minute only. And now this would mean that if the first monster who you choose to kill is this, then what does it mean? Will you be able to kill the other monster, which is this? The answer is no, because when the game starts, yes, you can instantly kill this monster with a feel that he is closest to you, but after that you will have to wait. You will have to wait for your weapon to get charged, because your weapon takes 1 minute to charge after every attack. And within that 1 minute, this monster will end up arriving. So this is the problem. But on the other hand, if let's say the first monster you had killed was this, the moment the game starts, let's say you kill this monster, that means you have gotten rid of this monster, right? And now what you can do is that you can wait. You can just go ahead and wait for 1 minute. When you wait for 1 minute, what will happen? When you wait for 1 minute, the distances of the other monsters would be updated. So this monster was initially at a distance of 6 kilometers, and now after 1 minute of time it will be at a distance of 4 kilometers. So I'm just writing it here. It will be at a distance of 6 minus 2, which is 4. This monster is already killed, and this monster would be at a distance of 15 minus 3, which is 12 kilometers. So now you'd want to kill probably this monster, okay? And then in the next minute, after next minute, you can kill the other monster also. Just check that out. So the point is that we would not want to kill the closest monster. We would want to kill that monster who is going to reach us the fastest. Is this point making sense? That why we should be killing the monster who is going to reach us the fastest? Yes or no? Yeah. Okay, so that is going to be our strategy of killing the monsters, correct? Now if you have a look at any example, let's say this was your example, it has been very well illustrated over here. So they say that if let's say the monsters are at these distance, so we all know that if we calculate after how much time they are going to reach us, here it will be 1 by 1, which is 1, here it will be 3 by 1, which is 3, and here it will be 4 by 1, which is 4. So to start with, I would want to kill this monster. So this monster is gone, he is killed, okay? And after that, what will happen? After that, we would want, so see, the moment you have killed this monster, 1 minute has elapsed. Because 1 minute has elapsed, so you can subtract 1 minute from here as well as there. And now what do these updated times refer? These updated times refer that, okay, the monsters which are available are going to reach you in 2 minutes and 3 minutes respectively. So now, which is the monster that you would like to kill? This monster. Can it be killed? Yes, because it is still away, so it can also be killed. Now you'd want to update the arrival time of this, because now 2 minutes have elapsed, first after killing of this and the killing of that. So because 2 minutes have elapsed, so you'd want to do a -1 again from here. So now again you can see that the third monster is going to approach you after 2 units of time. So can it still be killed? The answer is yes, it can still be killed. So you kill and then you go ahead with it. So that is how all the 3 monsters could be killed over here. But let's say you had a slightly different test case. You had 1, 3, 4, okay, and let's say this value happened to be 4, okay. In this case, can you tell me what would be your answer? What is the maximum number of monsters that you could have killed in this particular scenario? Okay, so 2 of you are saying that the answer is 1. That's right. That's right. So if you track down their time taken to arrive, then you are going to get numbers like 1, 3 and 1. Now you have 2 choices. You can either kill this monster or you can kill this monster. So let's say you kill this monster. If you kill this monster, that means you have made 1 kill, but now the time taken to reach will be updated as 0 and 2. 0 means that this guy has already arrived. because the 1 minute time which your weapon took to charge, in that much time this monster already arrived. Now because it arrived, so the game is up, you're doomed. Okay, so what comes to your mind? How many of you feel that we need to perform some sort of sorting over here? Do you believe anything like that? And if yes, then what is it that you want to sort? Do you want to sort your distance array, or do you want to sort your speed array, or do you want to sort your time array? You'd want to sort your time array, because to start with you want to kill the monster whose time is smallest, and then the next, and then the next, and then the next. This is how you want to go ahead. Okay, there is one more thing. In this question, when we are computing time, we are going to divide two integers, and when you divide two integers, the result can be a floating point value also, isn't it? It could be a double, it could be a floating point value. So what would you want? Would you want to store these time values inside a float, inside a double? What would you want? So ideally you would say that the best approach is to go for float or double. I would say floats and doubles also have some precision values. Okay, so of course you can go with it, and in most of the test cases, if you are lucky, then things might be good. But what I would say is that, hey, you don't really need that. You can get your job done by taking seal also. So as Rachit is saying, what is the meaning of seal? Seal means rounding off to large one or to large value. Because guys, just think of it in this manner. If let's say there was a monster whose distance was 9 and speed was 2. So if the distance was 9 and the speed was 2, can you tell me for how many minutes this monster is going to stay away? For how many minutes this monster is going to stay away from the city? So if you do a proper division, you would do 9 by 2, which is going to be 4.5. But can I also say something like this, that hey, I can probably place this number as 5. Why I can place this number as 5? Just think of it in this manner. It is guaranteed that the distance of this monster would reduce from 9 to 7, from 9 to 7, from 7 to 5, from 5 to 3, and then from 3 it would reduce to 1, right? And when it has reduced to 1, then it doesn't mean that the monster has already arrived. The monster is still away. Do you understand my point? So I can say that after 4 units of time, 1, 2, 3 and 4, after 4 units of time, the monster would still be away from the city. And because the monster would still be away from city, so I can take a seal and store that value over here, because I know that weapons take 1 minute of time to recharge, right? And if the monster is still away, I do not care how away it is. If the monster is still away, that means the monster can be killed. So what I can say is, if the remainder of division of distance with speed is greater than 0, if the remainder is greater than 0, that simply points to the fact that the monster is going to stay away for the next 1 minute also. And because it is going to stay away for next 1 minute also, I can take a seal. I can basically do a +1. So 9 by 2 plus 1 will be 5. So does it make sense to everyone here that why rounding off to larger value is going to suffice rather than having a float array or double array? Yeah. Okay, so if these many things make sense, then there is nothing special that remains with the question, to be honest. So I have written the code. I'll just show you the code here. So I have created a new vector called as times, in which I am going to store the time of arrival. And I have done nothing. I have just iterated on this array, and this is the expression for calculating time. So it's a ternary expression, but I believe you can understand it. This ternary expression simply says that if the remainder is 0, if the remainder on division is 0, then the time is going to be exactly this. And if the remainder is not 0, if the remainder is not 0, that means we will do a +1. So this is the rounding off part that I just talked about. Okay. Then I have sorted this times array in ascending order. And then I have initialized my answer to 1. If you're wondering why I have initialized my answer to 1, because my weapon is initially fully charged when the game launches. And as we discussed, all the monsters are away. So I can definitely begin by killing the first monster, or I can definitely begin by killing the first element of this times array. So I have initialized my answer to 1, and now I am iterating on my array from index 1. So I am going from index 1 till the last index. And all that I have to check is if times I minus I is greater than 0, then I am going to do answer plus plus. Okay, what is times I? Times I was the value which we had calculated. It told us that, okay, after these many minutes, the monster will be at your door, right? And now if your loop is running in ith iteration, what does it mean? It means that I minutes have already elapsed. Why I minutes have already elapsed? Because the moment you kill a monster, your weapon takes 1 minute to charge. So it means that if you are running ith iteration, in the ith iteration, the amount of time that will be remaining will be times of I minus I. And if this value happens to be positive, then you can do answer plus plus. Correct? The moment you find that this value is 0 or negative or whatever, you can break, because that means that a monster has arrived, and then your game is up, right? And then finally you can return your answer. Is it clear? How many of you understood this logic? So this was the I would say the most important thing was this, to sort on the basis of times, and then this part was just a small one. It's a long code. Okay, cool. Yeah, so what is the time complexity? What is the time complexity of this particular algorithm? So what is it that we are doing? This loop is running for n times. Imagine if there are n values in your distance and speed array, so it is going to run for n times. And then you are sorting. Your sorting is going to take n log n time, right? This loop is also going to take n time. So in order of n log n time, we have been able to solve this question. Sorting was mandatory over here. Without sorting, we could not conclude this, right? If the question asked to minimize the monsters arriving on the city, then we would need to recurse, right? Minimize the number of monsters arriving on the city. That is a good food for thought. You think about it, then the question becomes very different. Little different. I'll give one more food for thought. If you guys were there in yesterday's class, we had discussed a solution by using heap. Do you believe we can solve this question by using a heap also? Heap or a priority queue, whatever you call that. We can, and you should definitely think about it. Okay, cool. However, I'm not sure if you will be able to beat order n log n time using a heap. It will still end up consuming that much time only. Okay. So go ahead and think about it and try writing some code based on that, and see where it goes. Yeah, cool. So I think that was it about this question. It was a simple question based on greedy algorithms. Usually with greedy algorithms, what happens is when people look at a solution, they get biased and they believe it that yeah, the solution is right. It is uh, this is what is right. But it's very important to understand that why sorting based on times was important, or sorting based on some other parameter would have gone wrong. So all these ideation is very important before you conclude on writing the code or anything. Yeah, so that will be it. Let's probably, I think this week we are seeing a lot of questions which are based on um, kind of, I would say, maybe sorting or greedy algorithm or heaps, right? So it's a good idea if you guys, if any one of you want to revise priority queue heaps, you can do that. Yeah. Okay, great then. So let's end it here and let's meet again tomorrow with the new question. Okay, bye and good night.